Okay, so we pose the question, is the average height closer to 0 or 4? Okay, and of course we completed this question. Minimum height is 0, maximum height is 4. 0 occurs at the origin, 4 occurs at 10. Is the average height closer to 0 or 4? How much closer? What's your best guess? We got guesses of 0.1, 1.6, 2, and 3. So all over the place. And that's good. We have a good difference of opinion. It's too bad we aren't physically in a classroom where you could fight over it. But it might be an unequal fight. The smallest person would probably win. Okay, now I don't know how big you all are because I don't get to see you. I think, I know a couple of you, but okay, level surface is A equals 1. That means the surface 0.04 x squared plus 0.01 y squared equals 1. And I say level surface, I should have said level curve z equals 1. I'm imagining the thing up on the surface, and I wrote the wrong word there. Okay, this is ellipse, and I'm just going to sketch it. And we know what this ellipse is, because we've seen it before. If this is x and this is y, the ellipse has a semi-minor axis of 10 and a semi-major axis of 5. So we have, well, if we simplify this or express the ellipse in standard form, we find that the ellipse fits in a box that goes up to 10, down to y equals negative 10, over to x equals 5, and to x equals negative 5. And if we draw the ellipse within the box, as I said you need to be able to do, the ellipse looks something like this. Okay, now how does that ellipse fit into this picture? Well, we have to turn things so that the ellipse comes out to here and over to x equals 5 here. And we can see the ellipse within the circle. Okay, a circle of radius 10. It's already a bad start. Okay. I'm not sure already a bad start was a good construction. Well, this circle turned out not to be a particularly good looking circle, but we can still see that here's the ellipse and here's the whole circle. Every point inside the ellipse, for every point inside the ellipse, the height is going to be less than 1. For every point outside the ellipse, it's going to be more than 1. Turns out this ellipse has exactly half the area of the circle, although the way I've drawn it, the circle's a little too wide. So I can come in here and sketch that ellipse. Here's where x equals 5, here's where y equals 10. Here's the ellipse. And the height of the surface above this ellipse at every point is 1. So the heights are going to be 1, and I just draw a segment of height 1 at every one of these points, and then I can connect them. So right here is the section of this paraboloid, elliptical paraboloid, where the height is 1. Okay? Now, outside the ellipse, the height is more than 1. So we could look at the level curve z equals 2. So let's do the level curve z equals 2. And I should have figured this out in advance so I don't do something stupid and embarrassing, but I'm never reluctant to do that. So, okay, well then, the semi-major axis is going to be 10 over the square root of 2, which is about 7. And that's totally wrong. Semi-major axis would be 10 times the square root of 2. That would be up here. Semi-minor axis would be 5 times the square root of 2. That would be about 7. So the ellipse would start up here in my equation. I don't know how the ellipse gets into the equation, but okay, so it's like here, and then it comes down to a point way down here, and then it would be around here and down here, and you can work that out. But the part of the ellipse that's within the circle shows you the region of the circle where the height is between 1 and 2. Okay? Then we could do another ellipse for 3, and that would actually come out to about here. There's not a whole lot of the circle where the height is 3, between 2 and 3, and haven't drawn that real well. And then a little bit where the height is greater than 4. If you think about this and visualize it, and if you're good at visualizing, you can get a pretty good feel. So I'm going to write less than 1 here, less than 2 in this region, less than 3 here, and then less than 4 everywhere else. Okay? So, given this information, tell me again, how are you going to estimate, what is your best estimate of the average height of this graph above the XY plane?